Okay, next we're going to talk about comparators and mathematical operations and how that works with the MicroLogix series PLC. We're going to talk about things like the greater than instruction, the less than instruction, and then the different equal comparisons. And then also we'll talk about arithmetic operations within ladder logic. All right, so the next thing I want to look at are compare functions, things like greater than, less than, equal to. If we look across here on the bar here, we have compare instructions listed. And this is kind of small print. It may be very difficult to see. I don't know if I can actually zoom in. Well, I'll probably zoom in on this, but there's a limit test. We have things like masked comparison for equal, equals, not equal. LES is less than, greater than. We have less than or equal. We also have greater than or equal. So we have quite a few different instructions here that we can look at. And these are all very useful in decision making in our programs. And I plan on going through each one of these in a little more detail so that I can show you how they work. All right, so the first of the instructions I want to look at is the limit instruction. And this is a really useful one for where you have a low limit and a high limit. In this case, I'm setting a low limit of 5 and a high limit of 10. And we're looking at integer file N70, and we want to see if the value in here is actually within the range. Now, if I put a number in here like 56, and I can go ahead and just enter that directly. This would be something that might be a count value. It could be you're reading a pressure reading. It could be anything. I'm just changing the values here while I'm using the emulator. And you can see 56 is definitely not within the range of 5 and 10. Well, what if I make it a 3? Of course, 3 is outside of the range. So our output here, this test good bit, B300, is off. It's only going to turn on when our value is within the limit. But what happens if I make it a 7? Oh, look at that. As soon as 7 is within the range of 5 to 10, so our output is on. And now if I change this to a 5, it also remains on because the way this works is the low limit means equal to or greater. So we're actually, if it is equal to 5, that's our low limit. That's still good. That's still considered a good test. That's our minimum. But if I would drop that value to 4, of course, we're out of the range. The test is no longer good. And the same way, if I make this value a 10, it's considered a good test. That is our high value. So it's basically, it has to be greater than or equal to the low limit and less than or equal to the high limit. Again, if I make this N70 equal to 11, now we're outside of the limit. So this is a really useful instructions for checking to see if something is within, a certain tolerance that you've defined. And these low limits and high limits, these can be variable too. I could have used an integer file for the low limit. I could edit that and I could make this N71 and maybe N72 for the high limit. You can do things like that, and that allows you to change what your low and high limits are in the program rather than make them constant. It's a choice. It's really up to you. You have a lot of flexibility with that. All right, another very useful instruction is the equal instruction, and it's, basically is what it says it is. We're checking to see that the source A is equal to source B, and currently you see it is not. N70 is equal to 11, and we're wanting to compare that with a constant here of 5. Well, 11 definitely is not equal to 5, so our output here bit, this B30, and when I say output, I mean output on the rung. I'm not referring to a physical digital output. The output on the rung is actually an internal bit file or a bit, which is B301. So I want to make that clear too. But if I change the N70 to a 5, well, look at that. All of a sudden, our output is on. So this is a really good instruction. If you want to check something's equal, you want to use this EQU, equal instruction. And again, your source B could also be a variable. I could have used an integer file for that as well. So you have choices there. All right, here I want to test the two instructions and show you these. It's the greater than and less than, and I wrote this run a little bit differently. I'm using a branch, and just think of a branch as an OR. I'm basically saying in this case, if N70 is greater than 50, then I would turn on this bit B302. Or if N70 is less than 3, I would turn on B302. So when things are in series, you want to think of them as an AND, that you need all those things together to occur. When you have a branch like this, you're basically saying N70 must be greater than 50, or N70 must be less than 3. Now let's see, right now, what have we got in here? We got a value of 5, right? So if I change N70 to 78, oh, look at that. This upper branch is made. That bit turns on, our output bit turns on. Now if I go make it 45, our output is off. Our output to this rung is off, B302. Now if I go and I change the value to a 1, this B302 is on because now the less than instruction is good because 1 is definitely less than 3, and so that is on. So again, you have equal, greater, less than, and there's some other modifications, or there's some other similar ones here. You've got not only do you have greater than and less than, you also have greater than or equal to, which is a GEQ. You have less than or equal to, which is the LEQ. The difference there is that, um, for example, with the less than instruction, you must be less than 3. You can see right now that that's not good because 3 is not less than 3. If this was an LEQ, a less than or equal instruction, then the output B302 would be on because 3 is less than or equal to 3 because 3 is equal to 3. So you have also the greater than equal to, less than equal to. Those are very similar instructions. And then, of course, you have the not equal to, the NEQ, which means that a number is not, source A is not equal to B. So these are all, very similar instructions that you can work with, some really good comparators. And the next one I really want to take a look at is it's maybe lesser used, but there's also a masked equal. It's a kind of a masked comparison for equal. And that one's a little more complicated. It's not very difficult, but I will talk about that one here really briefly as well.